Welcome to Brain Vision.
Decibels. What is the acoustic power output in watts of the speaker, assuming it radiates equally in all directions? I wrote down what we were given here. We're given that the decibel output beta is 115 decibels, right? We're also told that the distance away, which I write as R, is 9 meters. And then we're also going to use this constant I naught, this intensity constant, which is 1.0 times 10 to the minus 12 watts per meter squared. It's going to be used in the definition of decibels, okay? Well, the first thing we can recognize is that the power which we're trying to calculate, P, is equal to the intensity times the area, okay? Well, the area is 4 pi r squared. 4 pi r squared. Well, 4 and pi are obviously just constants. R, we know it's 9.0 meters, so we need to figure out the intensity. So we can use the definition of decibels, which says that beta is equal to 10 times the log, which is log base 10, of the ratio of I, the intensity we're trying to find, we need to calculate the power, divided by that constant I naught. Okay. Well, we know beta, we know I naught, we need to find I. So we divide both sides by 10, and then we raise both sides to the 10th power because that's log base 10. So to get rid of the logarithm, you have to raise both sides to the 10th power. So divide both sides by 10 and then raise both sides to the 10th power. We have I over I naught is equal to 10 to the beta over 10. Okay, solving for I is equal to I naught times 10 to the beta over 10. Well, beta is 115. 115 divided by 10 is 11.5. So this is 10 to the 11.5. Okay. Well, plug that into the calculator, 10 to the 11.5, multiply that by our constant I naught, which is 1.0 times 10 to the minus 12, 0.3162 units of watts per meter squared. So now we know I. So we can plug that into our relationship for power, which again, P is equal to I times 4 pi r squared. So we plug in 0.3162 for I, multiply that by 4 times pi r squared, r being 9.0 meters, and this is 322 watts. And box that in. It's our solution.